Hi, I am Teacher Daisy. Now, let's learn Form 4 Chemistry Chapter 4, Periodic Table of Elements Part 4. In this part, you will learn 4.6 elements in Period 3 and 4.7 transition elements. 4.6 elements in Period 3. Period 3 is located at third horizontal row from the top of the periodic table of elements. Sodium, Na, magnesium, Mg, aluminium, Al, silicon, Si, phosphorus, P, sulfur, S, chlorine, Cl, and argon, Ar, are elements in Period 3. All elements found in Period 3 have 3 shells filled with electrons. Changes in physical properties of elements across Period 3. When moving across Period 3, from left to right, number of protons in the nucleus in each atom increases. Positive charges in the nucleus, positive 11, positive 12, positive 13, positive 14, positive 15, positive 16, positive 17, positive 18. Number of positive charges in the nucleus increases. Nuclear attraction toward electrons in all 3 shells becomes stronger. All electrons in the shells are pulled closer toward nucleus. Atomic size decreases. Tendency of atom to attract electrons into the outermost shell from other atoms increases, hence the electronegativity increases. Changes in chemical properties of oxides of element across Period 3. Elements in Period 3 combine with oxygen to form oxide compounds. Moving across Period 3 from left to right, oxide of elements changes from basic oxide to amphoteric oxide, then acidic oxide. NaO and MgO are metal oxides. Basic oxides are the nonmetal oxides, which are able to react with acids to produce salt and water. Reacts with acid, Na2O reacts with 2HCl, becomes 2NaCl, and H2O, MgO, reacts with 2HCl, becomes MgCl, and H2O. Al2O3 is amphoteric oxide. Amphoteric oxides are the metal oxides, which are able to react with both acids and alkalis to produce salt and water. Reacts with acid, Al2O3 reacts with 6HCl to form 2AiCl3 and 3H2O. Reacts with alkali, Ai2O3 reacts with 6NaOH to form 2NaAiO2 and H2O. Aluminium oxide and silicon 4 dioxide are insoluble in water. SiO2, P4010, SO2, and Cl2O7 are nonmetal oxide. Acidic oxides are the nonmetal oxides, which are able to react with alkalis to produce salt and water. Reacts with alkali, SiO2 reacts with 2NaOH to form an A2SiO3 and H2O. P4010 reacts with 6H2O to form 4H3PO4. H3PO4 reacts with 3NaOH to form Na3PO4 and 3H2O. SO2 reacts with 2NaOH to form Na2SO3 and H2O. Cl2O7 reacts with H2O to form 2HClO4. HClO4 reacts with NaOH to form NaClO4 and H20. Argon is inert and does not form oxide. Changes of elements of Period 2. 1. Period 2 is located at the second horizontal row from the top of the periodic table of elements. 2. Lithium, Li, beryllium, Be, boron B, carbon C, nitrogen N, oxygen O, fluorine F, and neon Ne are Period 2 elements. 3. These elements are located in period 2 because they have two shells, filled with electrons. Moving across period 2, from lithium to neon, physical state change from solid to gas, atomic size decreases, melting and boiling point decreases. Uses of semi-metallic elements, metalloids. A semi-metallic element is an element that exhibits both properties of metal and nonmetal. Semi-metallic elements are located in between metallic and nonmetallic elements in periodic table of elements. The semi-metallic elements in each period: period 2, boron, B; period 3, silicon, Si; period 4, germanium, Ge, and arsenic, As; period 5, antimony, Sb, and tellurium, Te; period 6, polonium, Po. Silicon and germanium are widely used in the microelectronic industries. They have electrical resistance between a conductor and an insulator. Silicon and germanium are suitable raw materials in semiconductor manufacturing. Semiconductors are used in electronic industries in the manufacturing of electronic components, such as diodes, transistors, microchips, and others. 4.7 Transition elements. Transition elements are metallic elements located in group 3 to 13 of the period table of elements. Transition elements are also known as transition metals. All transition elements exhibit metallic properties. They are much less reactive than the alkali metals. They do not react as quickly with water or oxygen as alkali metal. Metallic properties of transition elements: smooth and shiny surface, good electrical conductor, high density, high tensile strength, ductile, and malleable, high melting point. The bond between atoms of metal is called metallic bond, and usually, it is a very strong bond. For example, iron melts at 1535 degrees Celsius and boils at 2750 degrees Celsius. However, mercury is a transition metal, but with unusual low melting point, -39 degrees Celsius. Special characteristics of transition elements: 1. Have more than one oxidation number. Example: iron has +2 and +3 oxidation numbers. Copper has oxidation numbers +1 and +2. Manganese has oxidation numbers +2, +4, and +7. 2. Can form colored ions and compounds: Fe2 positive, light green; Fe3 positive, brown; and I2 positive, green; Cr3 positive, green; Cu2 positive, blue; CO2 positive, pink; Mn2 positive, pink; MnO4 negative, purple; iron 2 chloride; FeCl3 green; iron 3 oxide; Fe2O3 brown; copper 2 sulfate; CuSO4 blue; potassium manganate 7 KMnO4 purple. 3. Can act as catalyst in specific chemical reactions. Catalyst process: iron Haber process, vanadium 5 oxide contact process, platinum Ostwald process, copper 2 sulfate. N reacts with H2SO4 to form Z and SO and H2. 4. Can form complex ions. A complex ion is a polyatomic ion, positive or negative, consisting of a central metal ion with other groups bonded to it. Example: hexaqua cobalt 3 ion. Hexa means 6 aqua, means water molecules. The chemistry form for Chapter 4 concept map is as below. If you like this video, don't forget to like, share, and subscribe to our channel. Thank you.